Couple reminders. Tomorrow, yes, you can have your progression sheet, and yes, you need to have a calculator. Will I have calculators for you to share?
No.
No. Gotta have your own. Okay. So, when I'm going through some of these algebra problems here, I want you guys to realize that there are more than one way, or there's more than one way to solve most of these. It just depends upon how you see it, how you visualize it to make it work. Okay? So, when number one, you're given a whole bunch of exterior angles. Now, the easiest thing to do is then to work into the interior angles. Now, when you have two lines that intersect, you get supplementary angles. So what's the supplement to 88? Better yet, what are supplementary angles at if equal? 180. So,
92.
thank you. Subtract out the 88. On the inside now, we have a 92. I do the exact same thing with the 127, and I get 53. Now, there's two ways to solve this problem now. One of the ways is to use what's called the exterior angle theorem. The angle on the outside is equal to the two angles on the inside it doesn't touch. So x is on the outside. It's equal to the sum of those two angles. So x would equal 145. Or, the other way to do it is, how many degrees are on the inside of a triangle? 180. Yes, ma'am. One of the first things we did in this chapter, actually I think it was in the first section, was something called an exterior angle. An exterior angle is the angle on the outside of a diagram. That angle on a triangle is equal to the sum, when you add them, two angles it doesn't touch. It obviously touches this angle here. It doesn't touch those two. That's all it is. Or, do it the other way. What's 92 and 53? 145. The sum of the interior of the angles is 180. If I subtract 145 from 180, I get 35. Which means this inside angle would be 35. Its supplement would be 145. Either way works. You're going to get the same result. Okay? It's just that sometimes it's easier to work with the more specific theorem because it's quicker. That's all. Am I going to yell at you if you do it either way? No. It's okay. All right? Same thing with the next one. Now, number two, it's the same idea. It's an exterior angle. It's the angle on the outside. That means that 117 has to equal x plus 66. But if you forget that, there's another way to solve it. I'll show you both ways. 117 is x plus 66. Subtract the 66, and you get 51. If you forgot how to do that, okay, if you forgot how to do that, all you have to worry about is finding the supplement. Well, what's the supplement to 117? 63. 63 and 66 subtract from 180, and lo and behold, you still get 51. Okay? There's more than one way to solve these problems. Okay. How many degrees are in a triangle? 180. So here you're just given different angle measures. Put them all together and set it equal to 180. Now, a lot of you guys are writing this down right now. Did you even try to do your homework last night?
I did, yes. There is some things I like to do certain ones. I did it differently.
And then you're left with a two-step equation. It doesn't say solve for the angles, it just says solve for x. Remember, a lot of times it could. Excuse me. You just have to read the question carefully. That's all. You're getting there. Number 5. Oops. Solve for x and y. First of all, you have to figure out what kind of a triangle it is. It's a right triangle, but it's a right isosceles triangle. When you have an isosceles triangle, you have congruent sides. The congruent sides point at the congruent angles, which means your base angles are the same. How many degrees are in a triangle? Take out the 90, what are you left with? 90, so that means both of these have to be 45. That's it. Isosceles triangles have congruent base angles and congruent sides. The sides point at the angles. That little square box means it's 90. Work from there. We get 28 and 29. Again, it doesn't say solve for the angle. It just says solve for x and y. If you did solve for the angle, they should both equal 45. If they don't, you screwed up. It's another nice thing about triangles is that you know what the angles have to add up to equal. Okay? Here's one that I said I goofed on. This goes really fast after you fix that. Excuse me. It goes all the way up like it's supposed to. Up. That's 60. That means this is 60. 60 plus 70 plus something equals 180. Well, that's 50. 50, 70, and 60. It's really fast. You're just using you're not, it's not supplementary, but you're using straight lines to measure to add them all up. That's how it works. And then drew it like that. And what's your mistake here, guys? I'll have to get that right. Or
You might want to get
I don't need that.
Did you get?
I know you can try home. Boo. What's up?
Did you get 60 on the other side because it's vertical?
That's the only way it works. When I drew it, I must have moved it as I was moving the ruler, and I just didn't catch it. So that's all. We did that one. This one, 8 is also very fast. Once you put in that extra tick mark, it's really, really easy. Come on, guys. Because now, what is that triangle on the right? Equilateral, which means all of the angles are how much?
60.
60. So you have 60, 60, 60, 30, 30, and 120, and you're done.
So what is that on the bottom?
Square.
It's
This means it's 90.
then both of the angles.
Oh.
This means overall this is a right triangle
Okay.
with an equilateral and isosceles triangle built into it. It's a very common diagram that we use a lot of. Yes, ma'am.
So.
Guys.
How did you do 180 minus 60 and then got 120?
Yep. Something. Okay. Yeah, like I said, this one's super fast once you realize that I put a tick mark in it. Perimeter, how do you find perimeters? So if you add up all the sides here, well, we have an equilateral triangle here because all of our angles are the same, which means all of your sides are the same. What do you do then to solve for x?
No, never mind.
Are we dealing with angles or sides here? Sides. Okay, guys, when you see tick marks, that means they're equal to each other. They don't equal anything else. they equal each other. You can't make sides equal to angle measurements. 3 sides don't add up to 180. You set them up equal to each other. 2x minus 3 is x plus 5. Now there's 3 different combinations you could have done to make it work. It doesn't matter which one you use because you should get the same answer. X is 8. Now that doesn't mean that your perimeter is 24 because that's the value of x, which you have to substitute back in. So when you substitute back in, you have to check all 3 sides to make sure that they add up, to make sure that all 3 of them are the same. So 8 and 5 is how much? 16 minus 3 is 13. 21 minus 8 is 13. Which means my perimeter is 39. Okay? Which means my perimeter is 39.
I kind of like added them all up together. Is that fine? Just like kind of put them all.
That's what I did. Yeah.
Okay.
That's all I did. Because you just substituted an x and did it a long way. That's
Yeah, but
fine.
like I just like to.
Ladies and gentlemen, enough!
No, what I did was like 2 times 8 minus 3 plus like and just like went in the line.
Yeah, that's fine. Yeah, you can do that. It's not a big deal. I did it this way because it's smaller chunks.
Okay.
Usually when you do smaller chunks, you're less likely to mess up on it. That's all.
Okay.
No big deal. That's fine. Especially if you use your calculator, you'll be all right. Next one needs a what?
Diagram.
When you do the diagram, it's really, really easy. But it's the idea that you have to draw a diagram. Draw the diagram, label, and you figure out what's going on. Side length of 27, an angle of 75. Angle F is 74. Is E 31? Why? Good. E is congruent to V according to your congruency statement. These two have to match up. No. The answer is no. It is not. So as you go through that, could you have gotten away without drawing a diagram to see that because you had angle B and angle E in the actual statement? Yeah, you might have been able to, but it's always easier if you put it together and show the picture. It's much, much easier to see. No, we get that one.
Some of these little ones were confusing me. I don't know why.
You just gotta be careful as you read them. You gotta remember what kind of triangles you have and how the angles match up and things like that. What
Did you do the first one?
we did yesterday, yeah. You start through on 14. You'll notice that you wind up with the triangle on the left, that GBD. Yes, ma'am.
I don't know if it was our class that got the first one because none of us had it.
Oh, we did it.
I don't have it.
I don't know.
No.
It could have been the other class.
Yeah, it wasn't.
Oh, that's right, because you guys kept talking. I didn't get to it. That's right.
Yeah.
Well, let's start with these two then first. So with this one here, if you look at the triangle on the left-hand side, you have a 30 degree, a 90 degree, and what's left over? 60. So that tick mark there is at 60 degrees, which means this tick mark at L has to be 60 degrees. You've got an isosceles triangle here, which means that 3x also has to equal because it's isosceles. That's really quick. But it's a matter of using the properties. Follow through the properties, subtract out from this 180 and set it up. Same deal on 15, kind of a triangle. Isosceles. You've got your legs that are congruent at RT and ST, which means the angles that are going to be congruent are which ones? R and S. So if R is X, what's S? What do all the angles have to add up to equal? There you go. What's x plus 3x? Using properties of isosceles or equilateral triangles to get yourself through it. Okay, that's it. It's interior angle sum. 13, all you have to do is vertical angles, and it's pretty much done. Bless you. So if this side's 2x, what's the other side? This is an isosceles triangle, which means the base angles are the same. Which means this one is 6x and 6. What do all three of those have to add up to equal? There you go. Six x, and 2x is 14, plus 12, 180, two-step algebra, you have a calculator, x is 12. Remember, you can always go back and substitute that in to make sure you got it right. Right? Right. Come in. Room service, housekeeping. Come back later, I'm doing the dishes. All right. 16, you've got what type of triangle? Vertex angle of how much? 40. How many degrees are left over for the other two? 140, which means each one of the base angles has to equal. There it is. So x is 35. 17, what kind of a triangle? It's isosceles, because you already have the base angles congruent, which means the sides opposite them are equal. Sound equal to each other. 2 steps. Base angles are congruent. And then again, number 18 mirrors out exactly what we did earlier. We have a isosceles right triangle, which means the base angles have to equal how much? 45. Each one of them is 45. Quick and painless. Okay. Very quick and painless for a lot of this. I honestly don't think there's a single one of them that was scary at all. Proof-wise. You have givens and proofs. Here you don't have to worry about CP, at all because it doesn't tell you anything but triangles. It's pretty straightforward. You have progression sheets, so everything, all your reasons are all right in front of you. It's a matter of making sure you know how to find them. Once again, I've stated this many, many times. If you're still having problems trying to find out where things are in your progression sheet, grab a blank one, rewrite it tonight. That way it'll help you recall where you placed things. It's a great study skill. Givens and proofs. S is a midpoint. Of QT. Which means you go and mark your diagram. Midpoints create congruent segments. Does it say anything about RU? Can I say anything about RS and SU then? Nope, can't assume anything. Go to your next given. Next given talks about parallel. When you're given parallel lines, it says on your progression sheet to look for a transversal, look for angle pair relationships. Well, this one's got 2 transversals. And it's pretty straightforward. Here's one, here's your parallel, there's your transversal. Alternate interior. Now, there's a bunch of different ways to set this one up. This is your classic bow tie. Could I say vertical angles now if I want?
Yeah.
Yeah. Now, there's, I think, about 3 different ways I do this. If I want to go and say, do the bow tie and say QSR and TSU are congruent because of vertical angles, then I would be done because I would have angle, angle, side, and that's fine. Or, if I wanted to use the other transversal, I could say Q and T, and it's the same deal. I could say angle, angle, side. That would have worked. If I would have picked angled Q and T first and then went to my vertical, I could have had angle, side angle. It really depends on how you solve this problem. The main gist of it is getting this far with your parallel and picking a set of alternate interior. You're going to either wind up with angle, angle, side, or angle, side, angle, depending upon how you finish it. It's totally up to you as you get to that point. Okay? Either one of them is fine. What's that? Okay. It's one of those types of proofs that you can have multiple, there's multiple solutions to it. And that happens a lot. Pretty sure we've done this proof like 15 times. Perpendicular, a segment bisector, and then we're going to show that segments are congruent. Remember, when you have perpendicular, there are multiple steps on your progression sheet that tells you what to do specifically. And you follow those steps. That's it. I know that I have perpendicular, so I go ahead and mark up my diagram where the right angles are being formed. Right there. Which means now I'm going to say that those right angles are created. That's what it tells me to do on my sheet. After that, I go and say that they're congruent because all right angles are congruent. Right off the progression sheet, you did not have to think about anything. All you had to do was look at the letters. Go to the next one. D bisects. Bisector does basically the exact same thing as a midpoint, but you just write it as a bisector. D bisects AC. On my sheet, talks about segment bisectors. It says 2 congruent segments are formed. Which ones? AD, BC. Definition of a segment bisector. One of the things that you have to do when you're dealing with a bisector, your reasons have to say whether it's an angle or a segment. That's all. It's the only thing. And hopefully you choose the right one. Be surprised. That's basically everything out of your progression sheet, those first 5 steps, which means you have to come up with one thing on your own. What do you think it is? Reflexive. Now we have triangles that are congruent because of what?
Side angle side.
Good. Now, one of the things that I would suggest is that if you've already written out something about angles, reuse those same letters. Usually, yeah. Because we already know that these two angles match up, which means those two triangles would have to match up just because you use the same letters. And we just say side angle side. And I think it was 2 segments, right? Yeah, that's it. What does that stand for again? What does that stand for?
Corresponding triangles congruent. What? I can't remember.
You're missing a couple of parts. Corresponding.
That's what. Wait.
Protected, yes. Corresponding protective. Coaches, turtles, couches. Corresponding parts of congruent triangles are congruent.
Calculators.
Down the street, walking boys with a nice
Tacos.
Cornbread.
Cucumbers, potatoes, corn, tacos, and cornbread. Oh, wait. Cucumbers, potatoes, corn, tacos, and chips. Cilantro, yeah. Thank you for helping me out, because I forgot. I was thinking of cilantro, pickles, cumin, tomatoes, and cinnamon.
You're welcome.
Number 20 is a little bit different from any of the other ones we've done. Very slightly different, but what's different with number 20? What's different with number 20 is that it's given you four parts of given statements. And basically what happens a lot of times, if you have that much stuff given to you, quite literally you have no work to do but write everything down that you know versus via your progression sheet. So when I start with this one, we have angles 1 and 4. Mark my diagram. It then goes to LM is perpendicular to MP. Now, think back on your progression sheet. It says now to do what?
Right angles.
State the right angles. Well, when I look where LM and MP intersect, they only intersect at angle M. So how many angles can I talk about then? Just one. All I have to do now is say is that angle M is a right angle. Because as you look at the rest of the proof, it's going to do the same thing now for angle P. So you can't say that M is congruent to anything until you say something about P. That's what's a little bit different with this, okay? Because you got two perpendiculars at 2 points. And that's just definition of perpendicular. I do the exact same thing for OP, perpendicular, MP. Because there I get the angle P is a right angle. Do we have 2 right angles on here? Which means we can say that they are correct. That's the only subtle difference between what we've done before. Okay. So from those first 3 givens, you've got 6 steps right away. Okay. So now you go to your next one. N bisected a segment. NP. So if it bisects it, the 2 segments that are formed are
Now, are ones like these with all these steps going to be on the test tomorrow?
They might be, but look at this. Is there
I know,
any?
it's easy. Yeah.
Yeah, there's nothing on here that you didn't have. You didn't have to come up with anything on your own. Oh, actually, I'm sorry. You have to come up with one thing on your own. No, there's no reflexive. What are we done?
The triangle step.
We're triangle step here. Why do we have congruent triangles? Angle, side, yeah. If you wrote down side angle, would I be mad at you?
He doesn't like
No. It's okay. I mean, we just don't normally say it that way, that's all. So then you just say your angles are congruent, your triangles, like, we'll say L, M, N, O, P, N. Just make sure you line them up right. And then we can do our CPCTC. I don't remember what the part was. L, N?
Yeah, and
That's basically what we're looking at here, guys. There's the stuff that we've done, the stuff that we've looked at, going back and going through all the different proofs that we have. If you think about everything we've done in chapter 4, we've probably done a good 40 different proofs. And really, of those 40 some odd proofs that we've done, there's probably only 8 different ones. Just different versions of them, different lettering, things like that. Instead of saying a midpoint, we might have called it a segment bisector, things like that. Yes, ma'am? Probably. Probably.
there's still one more proof. Hey, Mr. Murphy, can we do the one that's on the back?
No, because the one that's on the back, and I'll just show you this
I
real
didn't
quick.
understand.
No, I told you don't do it, that's why.
Oh, I didn't hear you say that.
You whispered it because you were mad at me.
Yeah, it's because you guys talk too much, so.
Well, and your thing wasn't working, so that's also why you were mad.
And I think they give you this and this, right?
They don't have it on there. You don't have tick marks on there.
No.
What happens here, what happens here with this one is that if you look at the big triangle becomes an isosceles triangle. If you have legs that are congruent, what do you know about the base angles? That's a step in a proof that we don't need to worry about. So then between these two small triangles, you get side angle side, which gives you corresponding parts of congruent triangles to get you to here, which then therefore gives you base angles into here as well, and you can because you can go and do a whole bunch of things. So it's nothing that don't worry about that. I'm not giving you anything with a proof that deals with isosceles or equilateral. When you deal with isosceles or equilateral, it's more like the algebra stuff that we did, where you have to be able to work your way through a diagram via tick mark. So don't worry about this one at all. Okay, don't worry about that. I know that I was showing the other class was that we've done so many of the proofs. There's really not any left that I can think of that we haven't seen. But people still ask questions about some of the algebra stuff and where some of the good review problems are. Guys, come on. And what I was going to say is that if you wanted to go through and look for some more interior angles, exterior angle stuff, it's in the book tab on there, and I think it starts at 282. So it's remember, the book tab that I have is chapters 3, chapter 4. So basically, if you scroll to the very end of chapter 4, you're going to find them. And there's problems in here for that. I mean, there's really not, we've done all the proofs. I mean, there's some stuff there. We're not doing anything with this coordinate geometry, so you don't have to worry about any of that. Excuse me. Be honest with you. Go through the review packet. Go back and look at all the proofs that we've done. Make sure your progression sheet makes sense. If you haven't taken a backup picture of your progression sheet, do so now. So that way if you come to school tomorrow and realize you don't have it, you don't go, oh, poop. Okay, because you're not sharing those things. You're not sharing calculators. Got to have your own stuff, guys. All right, that's the whole deal here, okay? Questions?